Law of sines, two triangles. Number 30 has two triangles. Okay. As we talked yesterday, guys, as we talked yesterday, one of the giveaways, one of the things that has to happen in order for it to wind up with a double triangle scenario is your given angle has to be acute to start with. And then usually what happens is that if your other two side lengths, if the side length opposite your given angle is smaller than the other one, it's also kind of a little idea that you're going to wind up with some funkiness later on. So like we did yesterday, we start by drawing it. 20, 10, and 11. Well, this is what we did in notes, isn't it? What was the other one that had two triangles then? Let me do the other one then. Was it 33? Okay, 16, 92, 32. All right, let's do that one. So is it A? Is 16 degrees. This is 33, yeah. Because I realized that I did the same one in class yesterday, so whatever. We'll do the other one. So, again, start by drawing it. 16 is acute. 32 is smaller than 92 last time I checked. So this is kind of like your setup that you might wind up the double triangle. So what you do is, which angle is this forcing you to find first? B. It's forcing you to find angle B because you have the side opposite. So, law of sines. Sine of 16 is to 32, as sine of B is to 92. Multiply both sides by 92, so we get 92 sine 16 divided by 32 gives me some decimal. Second inverse of my answer. And I get angle B at 52.42. Are we okay with that? Okay. So I know that B is 52.42. So in order to check to see if I'm going to have a secondary triangle as B prime, C prime, which is 16, this is still 32, A prime, and 92. What I do is I find the supplement to 52. And I get 127.58. That's my B prime. Now, here's the trick. Take your original angle C and add it to it. Yes, sir?
So the B prime is off the second triangle?
Yes. Is there still enough degrees left to make a third angle? Yeah. What I'm doing here is I'm checking the supplement of this, of the B, and then adding it back to the 16 to see if there's enough degree measures left to create another angle A. What happens is, and this is where, what do we get here? We get 143, so 180 minus my answer. So I can have a 36.42, a 127.58, and then the other one was 111. Okay. What's happening here for those of you guys that didn't see me drawing on the whiteboard on this side, because you can't, is that sine is positive in two quadrants. Because you have your xy values. Xy is positive in the first quadrant, negative x and positive y in the second. Well, remember we were discussing this before. This is cosine, this is sine, cosine and sine. So as you have an angle at 52 degrees here and change, there's another angle in the second quadrant that these two guys share the exact same y coordinate. That's why their sine values stay the same. So it is possible to bounce into a secondary quadrant. That's why the possibilities occur. Okay. So what you're doing is find the second angle, check its supplement. If the supplement has enough degrees with the original angle given, then you can have two triangles. Yes, sir?
That's why it's possible for two different angles to have the same
Yep.
side.
Yep. Because, okay, one second, Caleb. What happens when you look into this, if this is at 3, this could be at 4, so this ordered pair would be at 4 and 3. This would be at negative 4 and 3. Because your opposite, your theta value is still the same. If you use Pythagorean theorem, this is still a 4, this is a 3, this is a negative 4, and this is a 3. You could still find your hypotenuse. Your hypotenuse would still be 5 for both of them because it works. Because when you square something with right angles, because horizontal and verticals form right angles. That's why this works. Yes, ma'am.
So after you find the other angle and find the supplement, then you have to add the given angle to it.
Yeah.
And if it's less than 180 degrees, then there's another angle.
Yes, ma'am.
Then how do you do that?
You subtract from 180. That's the other angle. You would have 2 of the 3 angles in a triangle.
Wait,
So-
you have to move
Yeah, see what I did here? I had the 127 and 58. I added the 16 to it, and I get 143.58. That's what these two add together to be. What's left to make angle A? That's all it is. I'm just subtracting from 180 to get that leftover angle.
and then with whatever that equals to the other angle.
And then you just do law of sines again to find that last bit of side A. Yes, sir.
So if you check it and it goes above 180, you take the.
Correct. And then you know it's just one triangle.
And then which angle do you use to check A?
Yeah, you have to do it twice because then there'd be two different side lengths for side A. Then.
Oh, yeah.
Okay. So because you have the two different triangles, so that's basically all this works out to be. All right. So then you just do law of sines again with sine of 16 is to 32, as sine of 111.58 is to little a, and then sine of 16 is to 32, as the sine of 36.42 is to little a prime. And you get your 2 different side lengths. Okay. All right, let's do law of cosines real quick. Add to this. Law of cosines is like law of sines. What is it? Put them all together. Law of cosines. Law of cosines, you have to use law of sines. Go figure. What's up? Yeah, it's 13.6. I figured might as well just add the law of cosines in right away because if you have law of cosines, you only have to use it once, and then it goes to law of sines. The law of sines is easier to use than law of cosines, to be honest with you. The goofiness about law of cosines is the setup. You only use law of cosines if you have these two scenarios for triangles. Side angle side, or side side side. So, what's that?
Only those two?
Those are the only time you have to use law of cosines. I mean, you can use law of cosines for the other, but it's pointless because it's too much work. Okay, it's not like, I mean, I don't want it to come off that law of cosines is horrible, scary, bad, but there's a bunch more buttons and you can get lost in the algebra if you're not careful. And honestly, law of cosines it really is only like a 2-step algebra problem, but it's the setup that takes a little bit of time. Okay. So you use the law of cosines if and only if you have side angle side scenario, or all 3 sides. And really the rule is with this one, with side angle side, you're going to find the side opposite, the given angle first. And then if you have the side scenario, you're going to find the largest angle first. That's the only 2 rules you have to remember. Okay. Side angle side is going to force you to find the angle opposite. Side, 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 you have to figure out which one of the three angles will be larger than the rest. And we know that because the largest angle will be across from the biggest side. Very good. Now, what it looks like. Ah, okay, crazy. These are three different scenarios. Okay, what I want you to worry about, is that the given angle is going to be your A. The side opposite is your little a. Everything else is just the other sides. So think of it this way. Let me put this on a clean one. A squared, side opposite a given angle, is b squared plus c squared minus 2bc cosine of A. Look what's at the front and the back of that formula. Angle and its side opposite. Okay. The rest of it going in the middle. So if you have that, you've got the side opposite and that angle. That's why they write it out 3 times, because this could be a little b and this would be a big B. And what would be in the middle? A's and C's, and so on. They just write it out 3 different scenarios. I don't think it's worth it. Just remember the angle you're working with and the side opposite. Let me show you an example of an actual triangle. So triangle ABC. Little a is 12, little c is 16, b is 38. What did I say? 12, 16, and 38. What is this forcing you to solve for?
The opposite of B.
The opposite of b, very good. So it's forcing you to find the opposite of b. So what I'm looking for here is I'm going to find little b. So little b is going to equal the other 2 sides that I have minus 2 times those sides times the cosine of the given angle. Again, see how those pair up. What values do you know? Well, I know little a, little c, and big B. So we get 12 squared plus 16 squared minus 2 times 12 times 16 times the cosine of 38. Are there any variables on this side of the equation at all?
No.
This is the one that makes you really happy, because what do you have to do?
Plug it in.
Press buttons. Okay. So when you press buttons on this, remember, make sure you're in degree mode. 12 squared plus 16 squared minus 2 parentheses 12 parentheses 16 cosine 38. I'm typing it in exactly the way I wrote it down. I hit enter. That number equals what? B squared. How do you solve for B? Second square root of my answer. Boom. There's B. 9.87. Going to 2 decimal places. Are we okay with that?
Sure.
So this equals B. Do I have law of sines now? Yeah. Which angle am I going to try and find next?
Probably A.
Let's go to the next angle. Go to C. Because it's the next, I usually like to find the next largest one, because if you do the next largest one, a lot of times that kind of gets, if that angle becomes obtuse, you don't have to worry about the ambiguity. If it's acute, you still want to double check. Okay. So if I go to this one, I'm going to use B and its side opposite to solve for C. Always go to the largest angle. You always want to go towards the largest angle because that will help not worry about the ambiguous case. Okay. So, sine of 38 is to 9.87, as sine of C is to 16. And I think by now we know how to press the buttons. Why did you move? Do you see? Sorry, I got cold hair on the brain. Second sign of my answer. 86.41. Are we okay with that? All right. So now I have a C value of 86.41. Ah, is that a Q?
Yes.
What's the supplement to 8641? Check it real quick. $93.59. So if it's $93.59 and I add, and I bump that back around, was there going to be enough if I add 38 to it? Yeah? So did that mean I could line up two triangles in this case? It can happen. Okay. Law of cosine could still generate double triangles, just like we were looking at yesterday. You do the same little setups. Okay. So you fall back to what you did yesterday. So you have your first angle here at A. And we know that we can have a and whatever that one winds up at. Okay. I know we're short, but laws. I'm assuming law of sines is pretty simple, right?
Yes.
Yeah.
Yes, ma'am.
So 86 and 86 equal, and then multiply that over
The positives, yeah. And then you just use law of sines to find the rest of it. Let me show you the setup for the three sides. Yes, sir.
Is there gonna be like a calculator, portion of
This would all be non-calculator.
Okay.
I'm kidding. Yes, you have to have a calculator with this. That's why I'm doing all the trig stuff that you have to have the calculator for first, because once we get the calculator out of our system, the rest of trig you won't need one. You guys don't look really happy about that.
No, I have a big calculator.
You don't need one. So what do we have? 4 minutes. So we have triangle. Always find the largest angle first with cosines. Which angle are you going to find? B. So you do the same setup. E squared. And this is the weird part about the algebra. You're going to have a two-step equation that you'll work with pieces of. Okay. Let's see, we get 18 squared is 8 squared plus 13 squared minus 2, 8, 13, cosine B. This is, when I have to solve for the angle, I want to take a second and figure out each chunk. So what I'm going to do is 18 squared. $324. Thank you. Equals. Well, the next thing that I can add together is I can only add these two together because this is multiplying. So I'm going to write down 8 squared plus 13 squared. 233. Minus, well, 2 times 8 times 13. Think of this as 324 equals 233 minus 208 times something. Where do you move first?
Move back.
Nope.
Oh, you move the other one over there.
What do I have to move first?
The 3.
233. So you subtract your 233.
Did you do that math or not?
What's that?
233 minus 2.
No, because this is this is times something.
Oh.
This is the same thing as 3 minus 2x.
Okay.
It's just with bigger numbers.
Got it.
Okay. So 324 minus 233, I get 91. Now remember, that's a negative 208. How do you undo multiply? 91 divided by negative 208, I get some decimal. What does that decimal have to equal then? How do you undo a cosine then?
Inverse.
Yeah, so at this point now, with that decimal in your calculator, second cosine of your answer, you get 115.94. There's your angle. Is that acute or obtuse? Do you have to worry about anything then? Nope. And then you just bounce it through with law of sines. Let me give you about 4 of these, I think. So let's see, this is 13.6. It's 8.10. Well, actually, it's only 9.06. Let's do 18 through 22. 5 of them. Okay? Yes, sir. Yeah.